8 years. 8 years of my life. Learning something that most people still don't understand. It was the trigger. I was driven by complexity. It wasn't just about learning something new. It was a math problem, an encrypted partition that required a password. Once I found it, I know everything. What you're about to learn is precious. 8 years of brute forcing, searching, learning, practicing. Searching, learning, practicing. 1 hour. That's all I have. But I need footage. 2012. Blackmagic released their first camera. The Blackmagic Cinema camera. I'm taking it out with me. This is where everything starts. When you press the rec button, the light goes into the sensor through the lens. The motherboard transforms the light into data. The data gets stored. This process is called OETF, optoelectronic transfer function. All of this happens in the dark. In total silence. The metadata. The data behind the data. My job, before doing anything, is to make sure the project uses the right settings. I shot in 2.5K. It's a weird resolution. 23.97 frames per second. No sound. Nothing else to check. I keep this information in mind, and I create a timeline. The Blackmagic Cinema camera shot a raw sequence of images in a format called DNG. DaVinci Resolve understands what's happening. The raw data is automatically decoded, and it creates a sequence. But I need to make sure it has been decoded correctly. I need to go into the decoding section to choose how the data needs to be processed. I didn't tell you everything. I need to tell you about signals. Videos. Videos are sequences of images. 24, 30, 60 per second. Images. Images are signals. Luminance, red, green, and blue. YRGB. The primaries. I need a tool. YRGB gain. 4 signals. 1 control. Intensity. When the Y signal is lowered, the image starts disappearing. If you turn off the light, you can't see anything. It doesn't matter if it's there. It's not there anymore. Digital images work the same. When the RGB signal intensity is low, colors disappear. The image becomes black and white. Increase it, and the image becomes more colorful. RGB intensity together without luminance is saturation. Isolate and lower one of the RGB signals, and naturally the others will be more present. Lower the red signal, and there's more green and blue. Green and blue give cyan. Lower red, and you introduce cyan. Red and green give yellow. Red and blue give magenta. YRGB is used by 50% of the tools in DaVinci Resolve. The other part is HSL. Hue, saturation, luminance. 3 signals, 3 axes. The color, how colorful it is, and how bright it is. Everything in one interface. A matrix. One of the most precise tools for color correction. Videos. Videos are sequences of signals. Log videos use a flat signal, a low contrast image to prevent the signal from clipping. Crushed blacks, overexposed highlights. That happens when you shoot using a standard profile. Standard profiles are made to bypass color grading and output a video ready to be displayed. Log profiles are made for preserving the image signal. Preserve what we call the dynamic of the sensor. If you're not doing color grading, shoot using a standard profile. But if you're going to do color grading, do not use standard profiles. Ever. Shoot in log. A log image looks gray because of the way it's encoded during the optoelectronic transfer function. But there's a lot of data in it, especially if you're shooting in 12-bit, like I did with the Blackmagic cinema camera. I didn't shoot in log. I shot in RAW. I choose the log profile now. During the decoding process, when you shoot raw, you can change almost everything. That's the magic. But only if you understand the settings. This is called a CIE, designed in 1931 to represent the colors that our eyes can see when we look around us. We're more sensitive to green because we evolved in the nature. The CIE represents a lot of colors, a lot of data, more than any screen can display. Instead, this is what we display: a tiny space called Rec 709. That's our standard. With slightly more green, this is DCI P3, used in cinema projectors, and Rec 2020, designed for HDR videos. Ideally, the best professional displays cover 80% of it. Currently, nothing can entirely cover Rec 2020. We can capture a lot of colors, more than we can ever see. We make powerful sensors, powerful camera processing systems, but in the most positive scenario, we only display 50% of what we capture. Why record so much data if we cannot display it? For what happens in between: color correction, color grading. The more we have, the more we can play with. And that's the reason why this Blackmagic cinema camera records 12-bit footage, 4,096 tonal steps per channel. That's the data for the artist working behind the screen. Blackmagic Film Gen 1, the giant color space designed by Blackmagic. This is what we need: a wide color space. If I use a display color space to decode the raw data into a video, it will delete all the colors outside this tiny space. But I need them. My monitor cannot display the Blackmagic Film color space. It's covering Rec 709 now. Then what is happening? What am I seeing? I'm seeing an image that uses the Blackmagic Film color space inside a Rec 709 display. I only see 30% of the colors. I need to compress the color inside the Rec 709 color space. In math, this is a matrix conversion. DaVinci Resolve will do it for you. The working color space, the man in the middle. The conversion happens between an input and an output. Blackmagic film is the input. Rec. 709 is the output. The working color space is not Rec. 709. It is another wide color space, just like Blackmagic film, but this one is made for color grading, not for decoding raw, not for displaying. It is a working color space, designed for DaVinci Resolve tools. This is my playground. A color space is a gamma and a gamut. Log is a gamma used to encode luminance. Rec. 709 is a gamut used to encode colors. If someone ever used Rec. 709 to talk about a gamma, it's gonna be gamma 2.4, the standard for Rec. 709. DCI P3 gamut uses gamma 2.6, slightly darker, optimized for cinema projection. If someone refer to DCI P3 for gamma, it's gamma 2.6. We use the gamut to label a color space, but when it comes to recording, we use the gamma to label the color space. This color space conversion converts Blackmagic film to Rec. 709, the gamma Blackmagic design film to gamma 2.4, the gamut Blackmagic design film Gen 1 to Rec. 709 gamut. They tried to make it less complex by hiding the details. I need to see it. I need to know what's happening. There's something I didn't tell you. This entire project hasn't been shot using only this camera. One scene in particular was shot in low light. And this Blackmagic camera has one condition. It has a small sensor. It needs a lot of light to get a good image. I choose a different camera. I used my Red Dragon 6K. Same image ratio, 16:9, same frame rate, but different brand, different color space. I used the widest color space by Red, the red wide gamut, log 3G10 gamma. I can't change the color management settings. If I choose red white gamut log 3G10, the clips that uses the Blackmagic film color space can be affected. The solution is in the metadata. I need to communicate the metadata to DaVinci Resolve to help the software decode the image correctly. I need to select all the clips shot with the Red Dragon 6K and change the input color space to red white gamut and log 3G10. The image changed. The conversion to Rec 709 is now accurate. If the image looks too orange, it's a white balance issue. We will fix this later. Now, it's time to start. We don't have much time left. The light box. Everything, all the shots, everything is here, in front of your eyes. This is where we start. This is where we organize. A movie is a sequence filled with scenes. I select the shots from the first scene, add them into a group, and label it. Over and over. Scenes by scenes. And when you're done, only when you're done, that's when it really starts. The whole process. All the corrections. All the ideas. Everything is happening here. Inside these 4 dots. And the first one is called pre-clip. All changes, all corrections will affect the entire group. I need to monitor everything. I need everything in front of my eyes. Leveling and balancing. like sound mixing. I'm dealing with signals. So I did the same for the soundtrack. Leveling. Balancing. Leveling. Balancing. Leveling. Balancing. Leveling directly affects the intensity of the signal. Balancing affects the balance. It affects the intensity as well, but not uniformly. Exposure is leveling. Temperature, tint is balancing. Pre-clip does a global correction of the clips inside a group. I need to make sure that the global exposure is correct and the global balance as well. With the primaries, I have full control over the signal. Lift controls the bottom of the signal. Gamma controls the middle. Gain controls the top, the intensity. I use lift, gamma, and gain for better exposure. Lowering the lift while increasing the gain creates contrast. Balancing the RGB signal to get natural colors is called white balance. Each correction has to be separated using nodes. That's how it works in DaVinci Resolve. Each node processes the signal from left to right, input to output. I named them to stay organized. I created my encrypted language. LGG, lift, gamma, gain. WB, white balance. It's a good starting point. But in this scene, something happened. I changed the lens. It looks slightly different from the other shots of the scene. I need to do some corrections, but only on this clip, to match the rest of the group. And that's the next step. The clip section. I need to be prepared. This is the hardest part. I have to stay focused. The hardest part is not the correction. The hardest part is being able to see. Once I see it, once I find the problem, I know what to do. Leveling, balancing. Until this happened. This clip is different. I can't get it to work. The skin color is too close to the door in the back. When I increase the saturation of the red color, it affects the door behind. I'm balancing the whole image. I need to balance a specific area. Only a few pixels. I need a tool for that. I'm making a window to isolate the skin tone. I balance this isolated zone to match the clip. Since the subject is moving, I need to start tracking to follow the movement of the camera. It doesn't work. It's not clean. We need to try something else. We need a color matrix. A color matrix uses HSL color space. I can change the saturation of a specific color without affecting the others. The matrix, the curves, the color slice, same principle, different interfaces. This one works. What about this one? This side is overexposed, but the subject is perfectly exposed. We need to isolate the zone using the qualifier in Luma mode. It isolates a specific part of the luminance signal. I need the highest part, and I need to lower its exposure. It works, but it's not efficient. HDR wheels. HDR stands for High Dynamic Range. This tool was made to correct high dynamic footage. HDR footage has more luminance data to process. Lift, gamma, and gain are made for SDR footage with much less dynamic range. HDR tools cut the signals into multiple range, from the deep shadows to the brightest highlights, each of them isolated. We need the highest part of the luminance. This is where we find the data that we need. And now, we lower it. Much more efficient. HDR tools are useful even for SDR delivery. HDR is an interesting subject. It's a futuristic technology. But for now, it is not our standard. I'm done with color correction. It's not my favorite part, but it's the most important one. Everything I did was very technical. It's not what I like. What I like is making art. What I like is color grading. We're almost there. But before that, I need to do some relight. That's when I use parallel nodes. Parallel nodes split and blend the signal. All corrections happen at the same level. They affect each other differently. That's what I want for relighting. A more technical term for relighting is local contrast. Looking for an element in the image that needs to be isolated and leveled or balanced. But this time, it's not only about correction. I'm using the same tools, but now I'm more creative. Where should people focus? What's the subject? The element? That's the question that drives me. I want my subject to be more visible. I can make it more visible by leveling up the signal, but I can also make it more visible by lowering the level of the surroundings. Each node processes two signals, a YRGB signal and an alpha signal. The YRGB signal is the image. The alpha is the transparency. The mask. If I want to send a mask from one node to another, I use the alpha channel. If there are multiple masks, I use a key mixer to combine them into one mask. Local contrast. All kinds of shapes. All kinds of creative ideas. But the question remains the same. What should people pay attention to? What's important for the story? And when you answer that question, you're ready. Ready for color grading. I've been waiting for this. All the tools, everything I know, nothing matters anymore. The only thing that matters is what I see here on my monitor. It has to be what I want. I take inspiration from film stocks, movies, album covers. Once I found what I want, I start. Creative leveling, creative balancing, same axis, same tools, HDR wheels to have precise control over the signal and create a custom contrast curve. I care about luminance first, then about color. But there are no rules. Everything you did before was to prepare your playground. Color grading is art. But there's one thing, one secret that always works. It's called split toning, and it comes from film stocks. Kodak, Fujifilm. That's the secret. Kodak pushes the shadows to cyan and the highlights to red. Red and cyan, opposite colors. That's color contrast. And it's everywhere. But I'm not going to use any presets. I prepared this project for almost an hour. Not to apply a preset at the end. This is not an option. But maybe it is, if you're not an artist. An artist needs full control. These presets are called LUTs. If you're using LUTs and you're happy with the result, it's because you didn't have a comparison. That's a famous theory. It's good until you see a better version. I'm here to show you the better version. These LUTs are made by professionals using calibrated monitors. They're not from random people. But still, not enough. Because LUTs destroy the signal. If after a LUT I want to change anything, I can't. The data is lost. These LUTs are built for monitoring on set. But that's it. We have a whole playground. Why narrow it to a preset? I know why. All these tools, they could make you feel lost. That's why I created this. a solution that simplifies color grading, but without killing art. A combination of complex techniques I designed, all inside the easiest interface, using a few sliders. I called it Shift, and I'm going to start with this. Using the color grading section, I'm going to create a film look. I use the subtractive color slider to reduce the luminosity of the colors and create a pastel look. The color mix helps me preserve the skin tone. I use Shift X and Shift Y to recreate the Kodak look, and I use the burn slider to warm up the image. I take my time to find exactly the look I want. Until I'm done with color grading. And I start the final stage. The timeline, the layer on top of everything. This is when things need to blend. It affects the entire project. All the clips, all the scenes. I start with grain. Analog film grain. Not any grain. 35mm. The vignette, produced by vintage lenses. I like doing it myself, using power windows and gamma. And the last node is a clamp to prevent data loss. That's it. I'm ready to export. This is where it ends. The delivery page. Everything needs to match. The image ratio, the frame rate, the color space. I started by decoding the data. Now I'm encoding them, writing the metadata, one by one, carefully. Any mismatch will create a failure. Not a failure that will corrupt the video decoding. A hidden failure, the one no one sees. A silent failure. In this page, we avoid them. So I check carefully. I take my time. Then I choose the codec, the encoder that will compound all these datas. My choice is Apple ProRes 4444 XQ, a heavy file from which I can export again. A great option for storing a project and remaster it in a few years when the display technologies evolved. H.264 and H.265 are my choice for social media. Much lighter than Apple ProRes files, but more limiting. Designed for online streaming. With the bitrate set manually or automatically. The bitrate will directly affect the quality and how heavy the exported file will be. Each images could be 100 kilobytes, or they could be 1,000 kilobytes. You're the one in control. Only if you want to. Apple ProRes HQ for YouTube and Vimeo. Lighter than Apple ProRes 4444 XQ, but much heavier than H.264 and H.265. NDCP, Digital Cinema Package, for cinema projection, with more metadata, more to worry about, more delicate. Everything is ready. I'm ready. I'm not rendering the project. What I'm rendering is this video, the one that you're watching now.